Dear students, welcome back to the chapter Triangles. In this period, we will continue the exercise 7.1. Let me give you a quick revision of the criterions that we are following here. The first one is SAS, which means two sides and the included angle should be equal between two triangles. And the second one is ASA, which means two angles and the included side of two triangles should be equal. But remember, ASA can also be rewritten as AAS, which means two angles and any one of the side of two triangles can be equal. Let us see question 4. Line L and M are parallel and P and Q are also parallel. So you know, when we have two parallel lines, we can consider either alternate interior angles or corresponding angles. Here let us consider alternate interior angles. Between P and Q, you can see the Z shape, which means BAC. The angle BAC is the same as DCA. Let us write it down. Angle BAC is equal to or congruent to angle DCA, because alternate interior angles are equal. So we have an angle now. Now you know AC is a common side for the triangle ABC and CDA. So AC is common. And you know common sides are equal in measurement. So we have a side now. Now we are also given the lines L and M are parallel. So we have another set of congruent angles here because they are alternate interior angles. DAC is congruent to BCA. Angle DAC is congruent to angle BCA because they are also alternate interior angles. So we get another angle. So by angle side angle, ASA congruence, we get the triangle ABC is congruent to triangle CDA. That's what we have to prove. Let's move on to question 5. L is the bisector of angle A. L is the bisector of angle A, which means these two angles are equal. And BP and BQ are perpendiculars. So angle Q and angle P is 90 degrees. You know that AB is common between the triangle AQB and APB. So let us write down one angle, another angle, S side, AAS. So angle Q is equal to angle P, both are 90 degrees. So we get an angle. Again, QAB is congruent to angle PAB. Can you guess the reason? Good, because line L is bisecting angle A. L bisects angle A. So we get another angle, and now AB is common. So we get another side. So by angle side criterion, AAS congruence rule, we get the triangle APB is congruent to triangle AQB. That's the first part that we have to prove. Next, we have to prove that BP is equal to BQ. If you are asked to prove about the parts of a triangle, it is just simple. You just look at the position BP and BQ. They are the last two letters. So we can just write BP is equal to BQ because corresponding parts of congruent triangles are equal. That's all. Now moving to question 6. AC and AE are equal. AC and AE are equal. AB and AD are also equal. Now you have to show that BC is equal to DE. BC is the base of this big triangle and DE is the base of this big triangle. So we have to consider two large triangles. BAC and DAE. We are also given that BAD, which is a part of the gray triangle, is equal to a part of the blue triangle, which means there is a missing part. Let us name this as angle M. So the whole angle of the gray triangle is BAC, which is formed out of angle BAD plus DAC. So let us write down angle BAC, which is the big angle of the gray triangle, is equal to angle BAD, which is given to us, plus an extra angle, which is M, which is DAC, angle DAC. Same is the case with the blue triangle. Angle EAD is made up of angle EAC plus the letter M. So angle EAD, the blue triangle, is equal to angle EAC plus angle M, which is DAC. And we are given that these two angles are equal. So BAD is equal to EAC. And we are adding a fixed angle to both of this equation, which means the left side will be equal. Angle BAC will be equal to angle EAD because we already have angle BAD equal to angle EAC. We are just adding the same number to both of them. So the left side will be equal. Now what happened is we get one of the angle is equal. We get an angle. Now we already have two sides are equal. What are the two sides equal? AB is equal to AD, which is a side given. Also, AC is equal to AE. It's another side that's also given to us. So by side, then the angle in between, this is for the gray and this is for the blue. So side, then angle, then side. So by SAS congruence, those two triangles are congruence. Triangle BAC is congruent to triangle DAE. The question is to prove BC is equal to DE. Just look at the position of BC, first and last letter. DE is also first and last letter. You know the corresponding parts are equal. So BC equal to DE because corresponding parts of congruent triangles are equal. So what we had done is to the given angles we add the same angle M to both the gray triangle and the blue triangle. Let's move on to question 7 now. AB is a line segment, P is the midpoint, which means AP is equal to PB. And also they gave you that angle BAD is equal to angle EBP. Also, we have EPA is equal to DPB. These are the given conditions. Now, you know, in the red triangle, APD is made up of APE plus an extra angle here. Again, let's call it M, same like what we did in question 6. So angle APD is made up of APE plus angle EPD. Also in the blue triangle, BPE is made up of BPD plus EPD. And we know these two angles are equal and we are adding a fixed number. So the left side will be equal. APD will be equal to angle BPE because angle APE is equal to angle BPD given to us. So we have an angle now. And we already know P is a midpoint, so AP is equal to PB. AP is equal to PB because P is midpoint. And we are also given angle A and angle B are equal. Angle A is equal to angle B given. So this is an angle, that is a side. So we have angle, side, angle. So ASA. By ASA congruence, triangle DAP is congruent to triangle EBP. That's the first part. Second part, we have to show AD is equal to BE. AD is the first two letters and BE is also the first two letters. So we can write AD is equal to BE because corresponding parts of congruent triangles are equal. Well, let's move on to question 8. ABC is a right angled triangle, which is right angled at C. M is the midpoint, so we can say these two are equal. And DM is equal to CM, so these two are also equal. Now we have to show that AMC is equal to BMD. These two triangles are congruent, which is a direct question because you know this is a side, then an angle, a side. So these two are equal. So let us start. CM is equal to DM. It is given. So we have a side now. Angle AMC is equal to or congruent to angle BMD because they are vertical angles. So we get an angle now. And we have AM is equal to BM because M is the midpoint. So by SAS triangle AMC is congruent to triangle BMD. Now we have to prove that DBC is a right angle. DBC, we have to show that this is 90 degree. That is the question. For that, we are going to prove that DB is parallel to AC because angle D, which is MDB, because these two triangles are congruent, angle MDB is the same as MCA, corresponding parts of congruent triangles, which means we get that alternate interior angles are equal. In this, between these two lines, alternate interior angles are equal. These two angles are equal, which means DB is parallel to line AC because alternate interior angles are equal. If two lines are parallel, you know that same side interior angles forms the supplementary angles. We just proved that these two lines are parallel. So you know that the angle between them should be 180 degree, which means DBC, angle DBC plus angle ACB should be 180 degree because same side interior angles are supplementary. But you know that ACB is 90 degree. So angle DBC plus 90 degree is equal to 180. So angle DBC will be 90 degree, which means angle DBC is a right angle. Next, we have to show that DBC is congruent to ACB. DBC, the brown triangle is congruent to triangle ACB. We already know that DB is equal to AC. Angle we know that side DB is equal to AC, corresponding parts of congruent triangles. And we got DBC and ACB are 90 degree. Angle DBC is equal to angle ACB equal to 90 degree. So we get a side, an angle, and you know BC is common. So another side. So by SAS criterion, triangle DBC is congruent to triangle ACB. Now we have to prove that CM is half of AB. From this criterion, we know that the side DC and AB are equal. DC is equal to AB by CPCT. DC is equal to AB by CPCT, corresponding parts of congruent triangles. But you know that we need AB in the equation. So CM, DC can be written as 2 times CM. These two are equal. So we can rewrite DC is 2 times CM is equal to AB because they are equal. CM plus CM, which is 2CM. Divide by 2 on both the sides. So we will get the answer CM is equal to AB by 2. Hope it's clear. That's all for today. Thank you for watching and see you in the next period.